Hello students, welcome to Saurav Sir's classes. Today we are going to start with the topic limits. Okay, we are going to start with this topic limits. What is limit? Like the way you talk to your friends and everything, mind it, hold on, keep limit, keep a distance. Okay, like you had the social distancing, you had to keep a limit with people. So basically in mathematics also there is a limit. Okay, let me show you. Let me show you with an example. Let's take a function f of x is equal to 3x. Now let's start putting values. Let's say f of 1 will definitely give you 3. Let's do this. F of 1.9. What will f of 1.9 give you? It will give you 5.7. Now let's do one more. F of 1.99 is going to give you 5.97. Then again f of 1.999 is going to give you 5.997, and so on. Can you see what is happening? See, let me just highlight and show you, or do a different color. When I'm putting 1, oh sorry, so sorry. When I'm putting a 1, then I'm getting a 3. When I'm putting 1.9, I'm getting 5.7. When I'm putting 1.99, I'm getting 5.97. When I'm putting 1.999, I'm getting 5.997. So what is happening? As x is approaching to the f of x, the function is approaching 6. You notice very carefully, as these values are approaching to 2, these are the x values approaching to, the functional values are slowly approaching 6. What if I directly write the 2? If I directly write a 2 over here, if I directly write f of 2, you're going to get 6. But then that will not be the limit. Okay, that will not be limit, because you are directly putting the value of 2 and you're getting the 6. Over here we are trying to put the values as much close as possible to 2 to try and get possible close values to 6, and that is the basic concept of limits. Okay, now in limits we have two types. Okay, one is the left hand limit and the other is the right hand limit. Let me just show you. One is the left hand limit and the other is the right hand limit. What is the left hand limit and what is the right hand limit? Let me just show you first the left hand limit. Left hand limit. In left hand limit, see, this is how it is. I'm drawing the y-axis. Okay, that's not y-axis, because that is like gone away. So this is a proper perpendicular y-axis. This is the x-axis. Okay, let's extend the negative part of the x-axis also. This is x dash, this is x, and this is the y-axis. Now look very carefully. Suppose a graph is approaching from the left hand side, okay, and going away like this. It is a continuous graph. You don't have to pick up your pen to draw this graph, and this graph is f of x. This is f of x, and let's say some point A it is in here. Can you see that the graph is approaching? If you notice that the graph is approaching, just hold on, let's use another color. The graph is approaching A from the left hand side as well as A from the right hand side, right? The graph is approaching A from the left hand side as well as from the right hand side, right? Both of them, both ways it's approaching A. So the left hand limit is written in this form. Right? See, limit x tends to A negative means approaching from the negative. A negative means not minus A. A negative is not equal to minus A. Make sure you don't mix these two up. Okay, negative A to the A and negative on top means approaching from the negative side. The f of x is equal to, so as x tends to A, then f of x will tend to some limit L. Okay, some limit L over here at the y-axis. So this is the left hand limit. Similarly, if you are to find the right hand limit, it's very simple. It is approaching from the right hand side. So the second one, the right hand limit, it's approaching from the right hand side. That was the left hand limit. Now the right hand limit approaching from the right hand side. So limit x tends to A positive, f of x will be equals to L, some limit L approaching from the left hand side. Now if I am to give you an example on this, how we can find a limit that is approaching from the left hand side and the right hand side, let us consider a function. Then we will understand what is happening over here. So let's change the color. Okay, back to black color. Now let us find the okay, so I'm going to take a function f of x is equal to x square minus 4 divided by x minus 2, and x is not equal to 2, and of course it will become 4 when x is equal to 2. So let's find, alright, let's find the left hand and the right hand limit for this function. Okay, so let's write left hand limit. Just let's broaden this nip of my left hand limit. Left hand limit. So limit x tends to 2 negative f of x is equal to limit x tends to 2 negative. Now 2 negative means the function has two parts. One is equal to will be here, okay, equal to will not be here. The function has two parts. This is the first part, this is the second part. Here we will take all values that is not equal to 2. So this is not equal to 2, hence we are going to put that value, that is x square minus 4 divided by x minus 2, and this is going to be limit x tends to 2 negative x plus 2 x minus 2 divided by x minus 2, cancel them out, answer is 4. Why 4? We have to put the value of 2 because I told you that this 2 negative means approaching. This means approaching from negative side. Okay, it is not equal to minus 2. Alright, so now we have found that limit x tends to 2 negative f of x is giving you the answer as 4. So let's now find the right hand limit also. The right hand limit, the RHL, you can write as RHL. Okay, you don't have to write the whole thing. So what is my RHL? Simple, my RHL is this. Just one sec, let me just make this go up. So my RHL, just once more, little bit down, little bit. Okay, it's getting covered. Okay, it's okay, it's fine. RHL what my RHL will be, limit x tends to 2 positive f of x is equal to limit x tends to 2 positive x square minus 4 divided by x plus 2, x minus 2, my mistake, that was the x minus 2 over there. Every time I'm writing a wrong thing. Okay, now why did I take this part of the function? Because again it's not equal to 2, right? Again it's not equal to 2 because it's approaching 2 from the right hand side. This means approaching 2 from positive side. So similarly, what is the answer of this? 4. Okay, so very simple actually, nothing so difficult in this limit. So you have learned the right hand limit, how to find limit from the right hand side, how to find limit from the left hand side. When the RHL is equal to the LHL, then that type of function is called continuous. The function is continuous. Okay, but continuity we shall learn later on. Okay, because we are learning about limits, so we will have to learn the continuity later on. Let's give you another example. If I want to give you another example on this, so there's another function that we can take, that is, you can try this at home if you want. F of x is equal to x square minus 9 by x plus 3, keep it. If I take this function x plus 3, not x plus 3, let's make it x, yeah, you can take it x plus 3, doesn't matter. Okay, and check the continuity, or check the limit at x equal to 3. Find the right hand limit and the left hand limit at x equal to 3. Okay, so the left hand limit, that is the LHL, limit x tends to 3 negative f of x is equal to, of course, x plus 3, x minus 3 by x plus 3. Remove them, put 3, and you're getting a 0. Understood? Again, RHL also you can use the same thing. Okay, so very simple to understand limits. We will talk about limits more in detail because there are many more limits to be found out, but for today we can end it here, and we will continue this in the next video. Okay, so thank you very much, and keep taking as much help from us as possible.